Okay, so guys, here's F5. I'm actually going to do 6 problems from the practice. But if at any point you feel like, oh, I've got this, then you don't have to stay for all 6, all right? It might feel like overkill for all of them, but at least stick around for like the first few. Look at the notes for the rest, or you could stay for the whole video. It's up to you. All right. So we're going to find the derivative of these functions, of the g's. And you got to be asking yourself all the time which of these formulas you are using. So guys, the first thing that you do when you look at a function is you should ask yourself, is this function itself a product of 2 other functions? No, 2 other non-constant functions, because if there's a constant multiple, which is a coefficient, then you wouldn't use product rule. The constant multiple would just come down. The coefficient would just come down. So, guys, this function itself is a product of 2 other functions. So, I'm going to use product rule. So the 2 functions are x to the 5th and f of x. So I'm not going to use brackets. You could set up brackets if you want, but I'm just going to jump right to it because I think most of you are comfortable just jumping right to it. So the derivative of the first function is 5x to the 4th, and then the second function just comes down plus. The first function just comes down, and then you do the derivative of the second function. So the derivative of f of x is f prime of x. So there it is. All right, now this one. So the first thing that you want to ask yourself is, I guess, is this function primarily a product of 2 other functions, a quotient of 2 other functions, or is it a composition of functions, meaning that we would use chain rule? So is there a function inside of another? And primarily, guys, this is a function, a composition, a function inside of another, because we've got the secant is the outside function, and then the input of the secant is this other function, x to the 9th times f of x. So we're going to be using chain rule. X to the 9th times f of x, secant of blank. But then, so primarily we've got a composition of functions. That means we've got a function that is the input of another function. But then when you go to take the derivative of the inside, you see that the the inside function is a product of 2 other functions. So you're going to need the product rule here. Yeah, so the derivative of the first function is 9x to the 8th, and then you just bring down the second function plus. You bring down the first function, the derivative of the second function is f prime of x. Okay, so this is the derivative of the inside. Now this is the outside function. The derivative of the outside function is secant blank, tangent blank. That's a formula that you've got to know. And then it's the old inside that is going back in those blanks. Okay, so g prime of x is 9x to the 8th f of x plus x to the 9th f prime of x. And then this is times secant of x to the 9th f of x tangent x to the 9 f of x. That doesn't look great. Okay, so there's that. Now this one. Okay, so first, you ask yourself, is this primarily a product, a quotient, or a composition, which would be, inside, outside. So product, quotient, or inside, outside, maybe say that. This is primarily a product. So let me put a multiplication dot to separate the two functions. All right, so we've got our first function here, our second function here. So g prime of x, so I'm going right into product rule. The derivative of this is 60x to the 11th. And then the natural log of f of x just comes down, plus. Now the first function just comes down. And then I'm going to multiply it by the derivative of this second function. So f of x is inside, natural log of blank is outside. F prime of x, 1 over blank, and f of x goes back in. Okay, so I'm multiplying this term by this derivative here. And if I just multiply straight across, I could just put the f prime of x in the numerator, just like that. Okay. All right, guys, I've got 3 more on the back that involve quotient rule, if you want to stick around for maybe at least one of them. All right, this is number 18. Is this a product, a quotient, or an inside-outside situation? Primarily. Like there might be more than one, you might say yes to more than one of those, but like primarily at first glance, is this a product, a quotient, or one function inside of another? The answer is quotient. So you're going to use quotient rule. So g prime of x. So I'm jumping right into the quotient rule without brackets. Derivative of the top, bring down the bottom, minus, bring down the top, derivative of the bottom, all over the bottom squared. Okay. Now this one, at first glance, is this a quotient? Is the entire function a quotient? Is the entire function a product? Or is the entire function a composition, meaning there's an inside and an outside function? The answer is composition. So this is a chain rule situation. So inside, outside. So the inside is f of x over 7x to the 5th. The outside is sine of blank. Okay. Now, all right, so for the derivative of the inside, guys, this inside function is itself a quotient of 2 other functions. So we are going to need quotient rule on the inside. So derivative of the top, bring down the bottom, minus, bring down the top, derivative of the bottom, all over the bottom squared. Okay, that's the derivative of the inside. Now the derivative of the outside, the derivative of sine is cosine. So cosine of blank, but what goes back in the blank is what used to be inside. Okay. Finally, is this primarily a product or quotient or one function inside of another. You look at this function is, primarily a quotient. So I'm gonna jump right into quotient rule. The derivative of the top is just 1. You don't even have to write the 1, okay? I'm just gonna write it for our notes so we could see it. So derivative of the top, bring down the bottom, minus, bring down the bottom, and then the derivative, bring down the top. Bring down the top, and then we need the derivative of the bottom. Now the bottom is a composition of functions, one function inside of another. So this is f prime of x. The derivative of tangent is 1 over 1 plus blank squared. And f of x goes back in there. So we're multiplying x times this derivative. And if you just multiply straight across, you end up with this. Okay.